This problem features a disk from which I've cut out a square. The square, you'll notice, fits perfectly inside my circle. There are a few tricks to this that might not be readily apparent right off the bat, so we're going to have to use some of the rules that are specific in Chapter 9 to make this a little bit easier. First, let's get the area of the whole figure. Let's start with a basic piece from which we're going to be removing parts. So, diameter is 6, which means I'm looking at an area using pi times r squared. Remember, radius is half the diameter. Many problems are going to present to you a diameter all the way across the circle. Always convert that to radius before you get too far into the problem. Now I can go ahead and calculate that. I want to turn it into an actual decimal, specifically 9 pi, which is an answer in terms of pi. When I use the calculator to evaluate that, I get something on the order of 28.27. Now, you can leave your answer in terms of pi. It's just as good. Some students are more comfortable with that decimal. Always read the directions, though, because some will ask you to leave it in terms of pi, and then you don't have a choice. Now, I have this part I'm going to cut out. The key to this is to remember that squares are parallelograms. They're also rectangles. That means their diagonals are the same. So if it's 6 between these vertices, it's 6 between those. Also remember that squares are kites. Squares are rhombuses. Rhombuses are kites. So that means that the area is 1/2 the product of the two diagonals. Now there are lots of other methods you can use to get the area of this particular square. For example, you can break this down into parts that are 3 and 3, get the area of each of these 4 triangles, and add them all together. You could also use special right triangles to take the diagonal of 6, work it backwards to get a side, and square the side. You'll get the exact same area when we're done. The advantage of doing it this way is I have a lot less work to do, and I get some practice using the kite formula. So now I'm going to plug in my numbers. 1/2, 6 times 6. It's going to give me an answer of 18. So 1/2, 6 times 6 gives me 18 square units there inside my cutout. And again, you'll get the same answer no matter what method you use. And if you get something like 17.9, that's just a rounding error from whatever method that was. But we're going to end up at 18 once we do it correctly. Now, that's my cutout. So, I started off with 28.27 square units there. I believe this problem actually uses inches. So 28.27 square inches, that's the whole circle, from which I'm going to subtract 18 square inches as my cutout. My final answer then is 10.27 square inches for the remaining shaded portion.